Let's take a look at some Fundamental Theorem of Calculus Part 1 examples. Now, as you know, I generally like to save my examples for when we're together in person in class, but I've had many students have difficulty with the Fundamental Theorem of Calculus Part 1 examples in the past, so I figured I'd shoot a video and let you take a look at it ahead of time. These problems are not difficult at all once you get the hang of it, but it looks a little unusual the first time you see it, so it's totally understandable if you don't get it right away. So let's take a look at example 1. Now this question asks us to find the derivative. So remember, according to the Fundamental Theorem of Calculus Part 1, the derivative is just going to be the inside function. So if we want the derivative of this g of x, when we take the derivative of this, we're just going to get this inside function here where we replace the t with an x. So g prime of x is just going to be the inside 1 over something squared plus 1, and then we just simply replace that t with our independent variable x, and that's it. That's our final answer. Pretty simple, right? Well, I figure maybe we should look at a more complicated example, so let's take a look at example 2. When I look at example 2, they give me this function where it looks like an integral and the independent variable is in the numerator, is in the upper limit of integration here. And they want us to find the derivative of capital F. Now I want to draw special attention to this upper limit of integration. I want you to notice this is not just x. Not just x. It's in fact square root of x. So what does that tell us? This tells us we need to use the chain rule. Okay? So our outside function is going to be the function, the integral from 1 to x sine of t dt. And our inside function is going to be square root of x, or as I like to write it, x to the 1/2 power. All right? So when we take the derivative f prime, capital F prime of x, we need to use the chain rule. So when I take the derivative of the outside function, that's this part right here, this is where I use the fundamental theorem of calculus. So the derivative of this function, according to the fundamental theorem of calculus, is just sine of something. So I'm going to write sine of something. Now, according to the chain rule, I need to keep the inside function. So I don't just write x there, I keep the inside function of square root of x, and I'm going to write square root of x in here. And according to the chain rule, we need to now multiply by the derivative of the inside function. So let's multiply by the derivative of x to the 1/2 power. Okay? So just to make it perfectly clear, we just applied the chain rule, which was when you want the derivative of a composition of two functions, f composed with g of x, you take the derivative of the outside, you keep the inside, and then you multiply by the derivative of the inside. Okay, so let's finish off this problem. The sine of the square root of x simply stays there. Now I multiply by the derivative of the square root of x, which I've written in exponential form. So that's going to be 1/2 x to the negative 1/2. And this will be our final answer right here. All right, so I hope this is clear. The g of x in our case is what I'm calling the inside function. So this is the g of x right here. The little f, the outside function, is this thing right here. And we just applied the fundamental theorem of calculus to get this first part. Let's do one final example, shall we? So when I look at example 3 over here, example 3 is really interesting because example 3 has, well, take a look. Do you see what's interesting about this question? What's interesting is that you have a variable in the denominator, and you also have, in the lower limit of integration, and you have a variable in the upper limit of integration. So when we look at this, we need to split this guy into pieces. So let's rewrite this integral as follows. Let us take capital F of x, and let's split it into two pieces. Okay, we're going to go from x to 0, t cubed dt, and then we're going to continue and go from 0 to 2x t cubed dt, like that. And this is one of the definite integral properties, which said, you can sort of introduce an intermediate point and then split your integral into two pieces, going from the lower to the intermediate point, and then the intermediate point to the upper. When I look at this first term over here, I do not like that our variable is in the lower limit of integration, because our fundamental theorem of calculus, part 1, requires this variable to actually be up top in the upper limit of integration. This is easy for us to fix. We can just invert the limits of integration, but keep in mind that when we do so, we pick up a negative sign. So we're going to have switch this to go from 0 to x, but we're going to have a negative in front. And then you got t cubed dt. And the second integral, let's leave that the same. From 0 to 2x t cubed dt, like this. Okay? So now we can apply the fundamental theorem of calculus, part 1, to this first integral over here. So as we know, the negative is going to stay there. According to the fundamental theorem of calculus, part 1, the derivative of this term is just going to be the inside integrand, where we replace the dummy variable with our independent variable. So in this particular case, we're talking about our f prime of x now, remember. I simply replace the t with an x, I get negative x cubed. Okay, for the second term, we're going to need to use the chain rule again. So just as before, the outside function is going to be the fundamental theorem of calculus looking thing, from 0 to x t cubed dt, and the inside function is going to be 2x. So when I use the chain rule, I am going to take the derivative of the outside, and the derivative of the outside is going to be something cubed. We want to keep the inside function. The inside function is 2x, and then we need to multiply by the derivative of the inside. And the derivative of 2x is just 2. So we'll just multiply that by 2. Okay, so why don't we just simplify this a little bit, because we can. This is going to be negative x cubed plus 2 cubed is 8. 8 times 2 is 16, so that'll be 16x cubed. And this simplifies into 15x cubed. So this will be the answer to our question. All right. We'll work through some examples together in class, everyone. Take care.